Welcome everyone, this is Bob with OneTech. I'm here today to give you an overview of the MicroAI Atom on the ESP32 environment. We start by viewing the repository on GitHub. First place you will go to download, clone if you will, the repository for your own use. What we're looking at here is two different use cases within this repository currently. One is application performance management, or APM, and one is security. The security use case will be handled in a different video. This one is for focusing on the APM. Scrolling down the README file, we'll see the table of contents and overview, information about what this covers, the tools that are required. This provides you a link to download the tools you need, how to get started. And again, the two different use cases, APM and security. Each of these have videos. This one is the video we're looking at now, and PDF files to give you an overview of, not an overview, in detail of how to use this SDK. We'll look at that here in a moment. What I'd like to start with is the description of what the MicroAI Atom does. Essentially, it is a library that performs analysis on time series data. What we do is provide multiple channels into this MicroAI engine, and through its processing, it's able to perform multivariate analysis, the output of which will be used in various ways that you as a user will choose to use. It performs and outputs data two different formats, if you will. One, it will provide data to identify an upper and lower bounds, and again I will show that later in a demo in more detail. But what it provides is that upper and lower bounds and the current value of the data, and that can be used on a dashboard or whatever you choose to utilize it for. And the other output is an alarm to identify when each particular channel goes out of range and out of tolerance. Now, these boundaries change because of this multivariate analysis, and so that's why this provides much higher value than any sort of simple bounds checking, which is of course very easy to do in code. What I'm showing here is as you probably already noticed, the sensor values coming in, whether it's analog or digital, being processed by what we call Xcode. You can apply whatever filtering is deemed necessary at that point. All of the channels then get fed into the AI engine, and the output, as I referred to, is used to determine what you want to do with it. That can be sent to various types of servers. In our particular instance, I'm going to show you a use case where it's sending MQTT server messages, but you can use it however you wish at that point. What's shown on the right side is what is used for both generating a library or using the library. What I mean by that is there is the real advantage in this application is that the endpoint here on this platform is capable of being trained. The user puts the system into a training mode, and that takes the input data, generates model data as output, and gets stored into libraries. In this ESP32 example, we have an SD card that's used to store that library. Consequently, that data, those libraries, are read out from that SD card and utilized by the AI engine to perform its function in real time. The other associated blocks are showing how you can enable, disable that library. Currently, it's done in the demo by setting a switch in a configuration file. We'll look at that briefly in a moment. So that is a high-level view of the processing. What we'll do next is go right into the APM use case. At this level, we're looking at the project view of the data for APM. All of these files and directories would be inserted into whatever folder in your directory you wish to run this application on your laptop. What we're looking at here is, again, this SD card. This is obviously not the SD card. These are examples of the configuration data that will be utilized by the AI engine. So these are samples that we suggest loading onto the SD card for running the SDK. The second folder is the actual library. In here, you have the AI engine library itself and the header files that are utilized for that. The main directory has your main code, and the main file, if you will, is the ESP32 AI.c, and the other supporting files are MQTT and sensor. MQTT, as I mentioned in this example, shows how to send data to an MQTT server, and the sensors have the code to read the sensors that are provided by this ESP32 interface. The SDK document will go into more detail of what sensors we utilize and how that data is obtained. What I want to additionally mention is the SDK by default has MQTT output disabled, as well as the sensors. Very simple to re-enable them, and I'll just show you that real quick. On the .h file, we have conditional compile options that can be enabled or disabled for MQTT and sensors. By default, again, those are disabled so that you can come up to speed and have your system operating fairly rapidly. Back up, we have that's all the folders here and the miscellaneous files. One file I'll go ahead and jump to is that more elaborate SDK documentation file, and this is what you'll go through in more detail to give you an idea of what needs to be done to make changes, to utilize the X code in various methods, as well as the Y code to set up what data you're going to send out to the servers. And we have our table of contents. And more, again, we can go through a detail of what MicroAI is again for your more details. Okay, so that is the majority of the data that is in the repository itself. Now I'm going to jump over to a pre-recorded demo, and this will give us more detail of what is possible. This, again, is just an example of what can be done with this environment. What we're looking at here is a OneTech Helio dashboard that is on our server. This gives an idea of the kind of data that can be presented. In this particular application, what we're doing is we've monitored this Dobot brand robot in its operation, performing a repetitive task such that we can identify when behavior exceeds the normal bounds, and when that happens, it will generate an error. I'll start this real quick and show you one of the first errors that is demonstrated by the operator. You will see that in the upper right hand corner, where what he does is blows on the unit, and that will introduce additional heat and humidity for one of the sensors. When that occurs, an alarm condition is generated, and as a result, again, that is something that triggers a special message that can be sent out to whatever server is utilized. In this case, again, we are using MQTT, and that is sending out these messages to our server, and our dashboard here shows these various elements. The alarm section on the bottom actually shows each individual alarm as it occurs. We have these graphs that identify on these individual channels. In this case, we've got 4 channels being monitored. The upper and lower bounds in blue, and in yellow, the current value. You'll see here in a moment, as you see, the sound's already exceeded value for one of the alarms. I will go ahead and let it run. See, the robot is performing a regular function. On the right-hand screen is our typical output from ESP32 that is able to show the detailed data that's being output by the AI engine and being considered for sending to the MQTT server. The second error that's going to occur is the operator is going to impede the movement of the arm, and so in that case, the system will sense an error condition right there, and you see another alarm was generated. Consequently, the dashboard shows that as well. Now, at this point, the operator is pointing out what is being utilized on this demonstration. Here is the ESP32 board itself. He's pointing to one of the sensors, that's the temperature humidity sensor. Then the sound sensor is mounted on the side of the arm of the robot. We have an interface board there on the top that allows hooking up the cables. And then the accelerometer and gyroscope sensor mounted towards the end or the head of the robot. So all of that allows us to monitor the performance of this robot and generate the necessary alarms when they occur. So that is the overview, and I encourage you to contact OneTech for additional information and to get access to our repositories. Thank you very much.